Hi, today's concept is thread basics. What are the basic concepts of a thread? So today I am going to explain the how thread scheduler will behave like that. So before going to the concept, in real time, which scenarios we are going to use multi-threading? So there are some situations are there where must and should we need to use. For example, every web server like a Tomcat server or any application servers must and should need a thread concept, because coming each and every request it will converted as in a one thread, and that thread will execute your web application. So your main thread concepts are using in servers implementations. So, and not only server implementation, if suppose you have a two independent tasks, task 1 and task 2, suppose if you see here, I have a task 1 and a task 2, two tasks I have. So task 1 is not depending on task 2, so both are independent tasks. One task I have two tasks. Task is nothing but in a program I have a some logic, two logics I need to execute, but these two logics are independent logics. There are no dependency between task 1 and task 2. Then why should I wait to execute my task 2 until completion of my task 1? There is no need. So what I will do in these situations, I will prefer multi-threading concept, because my task 1 is different, my task 2 is different, both are independent. So first thread I will create two threads. My first thread will execute a task 1 and the second thread will execute a task 2 at a time. So there is independence. Then you can ask, if two tasks are if independent, maybe if the conflict is there any conflict will come if two tasks will execute at a time? Never. There is never conflict will come. Why? Because these two tasks are independent. Once whenever you need to go for multi-threading, if the tasks are job if independent to another job, then only you should prefer multi-threading. Otherwise, don't go for multi-threading. Okay, in future classes I will also explain, if one task is depending on another task, how to execute in that situations also we can provide multi-threading, how to overcome that situations I will explain in future sessions. But now you should understand, task 1 and task 2 are independent tasks. Then you should go for multi-threading, because no need to wait task 1 or task 2 in sequential order. Both are independent means I can execute in concurrent manner. Now you can ask, a thread will, what a thread will do? A thread will execute, a thread will execute a job. Every thread has, why we are creating a thread? A thread need to execute some job, to perform some job. What is the meaning of job? A job is nothing but a logic. Whatever the logic we are writing in the run method, that is called as a job. So once if you create a thread, what it will do? It will execute this job. What the job? Suppose here I am creating a thread. I hope you are in previous sessions I explained how to create a thread. Thread demo t1 equal to new thread demo. So I created an object of my thread, my runnable sub implementation class. Now can I call t1 dot start? No, you can't call, because it is an implementation of runnable, not extending. So what I will do, I will create a thread class. Thread equal to t1. Now I can call, now I can call thread dot start. Now which run method will execute? Your what object you are passing? T1. So T1 run method will execute. Okay. Now if you see the output, the run method, end of run method. So you are seeing end of run method. Now I will explain what are the states. It's not a mandatory. Now thread dot start. So here thread is started in this line. In this line or not? No, it is just we are invoking start method. After start method, automatically thread will be created by the JVM and it will execute. First line is, this is the first line, it is execute, and this is the end line, it will execute. So after this line and after this line, suppose after line number 6, the thread will be going to the dead. So you have thread object, but thread will be dead. You can't utilize the again same thread. If you call thread dot start, it will throw illegal state exception, illegal thread state exception it will throw. But the lifetime of a thread is, this is the lifetime of a thread. So what thread will execute? Whatever the logic inside of run method, it will execute. So that logic we can call as a job. So what is the job? The logic internally what we are implementing or writing inside the run method is called as a job. So every thread has its own job. If I create 5 threads, 5 it will execute 5 jobs. So that is the first one. The why we are going for multi-threading? Because the first reason, all servers are implemented threads inbuiltly. Okay, then why in Java application, if there are independent tasks, if you want to performance, increase the performance, then I will go to the multi-threading. But compared to other language multi-threading, is there any specialty in Java language? Yes, because it is provide inbuilt API for rich API for providing a efficient way of multi-threading, like thread runnable. Some classes it is providing runnable class, thread group. Some more classes will come in future, I will explain. So if already Java created these classes and given to us, so no need to we consider about how threads are executing, how one thread to shifting to another thread. No need, we no need to bother about these considerations. We just give effort on writing the logic, automatically threads will work. So it is giving inbuilt support in Java threads. So that is. And you can ask one more thing here, t1 dot start. Can I call instead of t1 dot start, instead of 31 dot start? Here what I am printing is thread dot current thread dot get name. If I print, what it will print? By default thread 0 will be print, because JVM will assign the name thread 0. Yeah, thread 0 if I print. So instead of calling start method, I will directly call run method. Yeah, I can also call run method directly, right? Now what will happen? Now in this situation you are directly calling run method. No, you are not calling start method. If you are not calling start method, what will happen? Thread will be not created. Now this code will execute or not execute? Which thread will execute? Main thread only. Main you are printing. Now what I will do means, I will call thread dot start and thread dot run, both I will call. Now 2 times run method will execute. First time run method will executed by the thread 0 thread created by the JVM. Now second time created thread is executed by the main thread only. So two threads is there. End of run, here if you see, main is under thread 0, 2 threads. So my run method is executed by the 2 threads. One is by main thread and one is by the thread 0. So if you call start method, what will happens? New thread will created, that thread will execute the run method. If you call directly run method instead of start method, what will happens? Run method will execute, but not by new thread. It will not create any new thread. By main thread only it will execute. That is the difference between the run method and a start method. If you can call, what happens if you can call with start method and if you can call with run method. Next point is, if you create a thread, who will take care? Suppose here I am creating one thread. So if I go to this thing, I will create one more thread. I will create two threads. I will create two threads. Now if I execute thread 0 and thread 1, two threads are created. Now what is the order of execution? Always thread 0 or thread 1? We can't mention like that. In this situation, first is run method is executed by the thread 1, second one is executed by the thread 0. In this situation, 0 and 1. Sometimes first thread is executing, sometimes second thread is going to executing. So in this situation, can we expect the output in multi-threading form? Because multi-threading means at a time more than one thread is running. So which thread is giving first output, which thread is giving second output, means the execution threads order can you set or can you expect? No. The execution order of a multiple threads, we can't expect. First this thread will execute, after execution T1, T2 will execute, like that we can't expect, because the threads are depending on your thread scheduler, OS level thread scheduler. Thread scheduler will allocate which thread need to execute and which thread need to in waiting state. You are not responsible for those things. Who is responsible? Thread scheduler is responsible. So in your operating system, suppose in my Windows operating system, the thread scheduler will implemented by which algorithm? I don't know. So based on the algorithm of thread scheduler only I can. Suppose if your thread scheduler can implement FCFS means first come first serve algorithm. In your Windows operating system, the inbuilt scheduler will be there. If the scheduler is FCFS implementation, means suppose I have a 5 threads. Which thread need to execute? Which thread came first? I need to serve that thread. Means T1 came first, so T2 next, T3, T4, T5. That like in this order, my 5 threads are came to my scheduler. Now which thread will execute? T1 will execute. After T1, T2 will execute. After T2, T3. After T4, after T5. Based on the first come first serve, means which thread is coming first, I will serve that thread. It is the implementation of FCFS. Otherwise SJF, suppose if your operating system is SJF, means I have a 5 threads. In that threads, 2 threads are very small jobs, means it's 1 second executions. Remaining 3 threads are 1 hour, half an hour executions. Now what your thread scheduler will do? If the implementation follows SJF, then shortest job first, means which threads are taking very less time to execute, it will execute those threads, and after executing those threads remaining based on the less time, it will execute the threads. Otherwise round robin algorithm. Round robin algorithm means some part it will execute first thread, other next it will go to next. In round robin algorithm format also thread scheduler can execute. Which format we can't mention, because your underlying operating system, based on the algorithm, what algorithm they are implemented, those things, based on that condition only threads will execute. Now here one more one is, can I overload a run method? A run method, can I overload? Yes, you can overload a run method. Suppose here if you see, I am overloading run method. Yeah, I am in I am in argument run method, argument of run method. Otherwise, yeah, I'm just printing, and I'm also printing. Okay, now if I call, which run method will execute? Here two run methods are there. First one is default run method, there is no parameters. Second one is parameterized run method. Now which run method will execute? By every time default run method will going to execute. Yeah, this is not executed. If you want to execute this one, what you will to do? Thread dot run, sorry, t1 dot run. Here by default run method will going to execute. I am calling parameterized run method explicitly. So can we overload run method? Yes, we can. But thread will not, every time thread will calls only default run method only. It will not call parameterized run method. Okay. Next, can we overload start method? I have a doubt. Can we, suppose it's a extends, my class is not implements, extends thread. Now no need to write like this, right? I can directly call t1 dot start. Yeah. Now t1 dot start, in this situation I can print thread 0. Yeah, thread is created, the thread is printed. Now what I will do, I will override start method. End of start method. Now if you call, now what is the output, expected output? Is the run method will called or not? Never, it will not call run method, it will call start method only. So if you override the start method, thread will created or not? Not, it will not create the thread. So that's why it is printing end of start. But I want to create a thread after overriding of start method. Is that possible? Yes. After overriding of a start method, we can also create a thread. How can I? Simply, sorry, super super dot start method. Then which start method will, I will call my start method, and my start method will call super class. Super class is thread. So thread class start method will execute. In that thread class start method, thread will be created, and that thread will execute my run method. Now I hope you understand, right? Yeah, here if you see, start method means this line is executed by the main thread only, but this line is executed by the thread 0. Thread 0, this is the line is executed by the thread 0, and this line is executed by the main thread. Why? Because in this one, in this scenario, I created the thread. Suppose if I comment thread super dot start, what will happen? Thread will create or not? It will not create. If you run here, only main thread is printed, thread 0 is not printed, and run method is not executed. Why? I commented super dot start, and means I didn't created thread. So Is that mandatory to override start method? No need, don't override start method. Suppose if you want to override the start method, you must and should call the super dot start. It's a mandatory. So this is the main difference between a start method overriding and a run method overloading, and a thread scheduler implementations. These are the main concepts. Okay, so in next session I am going to explain about thread states. What are the states of thread? And one more class is one more enum is there, thread dot states enum in java dot lang package. What that enum will do, what are the states of thread, how to find the each state of a thread. So these are the concept. Thread life cycle, what is the life cycle, when thread will be created, when thread will be going to the dead, and what are the states in between the threads, how to find the states, can we change the states, like that. This much of information we will get in, I will going to explain in the next session. So thank you.